So today we are going to solve GFG problem of the day, that is alien dictionary. So the question is, and also it's a 8-point problem. A new alien language uses the English alphabet, but the order of letters is unknown. I mean, it's not like ABCD, it's something different. You are given a list of words from the alien language dictionary where the words are claimed to be sorted lexicographically according to the language rule. So they have some sort of language rule and you have to frame it accordingly. I will explain it with example. So your task is to determine the correct order of letters in this alien language based on the given orders. And if the order is valid, return a string containing the unique letters. And if there are multiple valid orders, return any one of them. If the given arrangement of word is inconsistent with any possible letters ordering, return an empty string. I mean, if it doesn't make any sense or it's inconsistent, then you can return this as this. So if I'll explain with this test case, so what you're supposed to do. So like as per us, it's first A, then B, then C, then D, right? But as per them, let's compare this and this. So anyhow, in this B comes first, then A comes. I mean B is before then A, so we'll write as like this. Now let's compare these two letters and A, B, C, A. First we'll compare A and A, it's same, then B and B, it's same, C and C, it's same. Now D is coming before then A, we'll write it as D of A. Then we'll compare ABCA and CAB. And also if we'll compare, we'll get to know that A is coming before C, so we'll write it as like this, because we compare the very first element, and if it's not same, we'll directly put it. And at last it's CAB and CAD. And we'll see that initially first letter is same, we'll jump into the next, it is also same, then coming to third letter B is before then D. So after this, what we'll get to know, that B is before A, D is before A is before C, so we'll get to know that C is at last, but also we will get to know that A, like B and D is before A, so we'll compare B and D, and B is before D, so we'll write it as B, D and AC. So this is as per the alien dictionary, and this is we are supposed to find out. So I will explain it side by side by C++ code. So first what we will do, we'll declare something unordered map, and inside it we'll write as char, and let me write it as unordered set. And we'll give the name as graph. So we are making the keeping the track of all the attached letters with any particular letter. I mean, what all letters are very adjacent to it, right? As I told to it, A, B, D, A. So it will store all the adjacent letters. On the same time, we will declare another unordered map, and will store character and int, that is something called, my bad, int degree. So it's basically that it's an unordered map. So here the int degree of A is 1, like B is coming towards A. Here on the same time it's again 1. Here for C int degree is 1. Here for D int degree is 1. So it's like that. So we are storing the character and its int degree. So I mean, if you'll see that A has in degree of 2, I mean B is also coming towards it and D is also coming towards it, so it basically stores that in a map. And once we have stored both the values, we'll try to iterate something by declaring word, and we'll go through all the words, I mean all these words, we'll go one by one, and while going inside it, we'll store it in the graph as ch, so that we can make sure that every character is in the graph. And next to it, we will declare in degree initially as 0, I mean nothing is going inward, I mean that's what I told, right? So once we are done with this, we'll go inside a for loop, we'll go till the word length, and while iterating through it, we'll store w1 as words of I, and string, let's say w2 as words of I plus 1. That's what I showed here, right? We are comparing one by one. This is I plus 1. Next time this will be I plus 1. So it's like that. And once we are done with this, we'll declare something called length as a minimum of w1 dot length and w2 dot length. So as we know that one of the word might be shorter and other might be larger, so that we will go till I equal to 2 in spite of going I equal to 3, because there is no element to compare it in I equal to 3, right? So it's like that. We will get minimum of both of them, and initially we will declare found as false. Now once we have got the word, we'll iterate inside it so that we can iterate side by side characters, that is A, B, C, D, whatever, let's say, and inside it we will iterate. And also we'll check if w1 of j is not equal to w2 of j. It means if two characters aren't same, like D and E, till C all the characters are same, but once we check that these characters are different, we'll declare character of u as char u as w1 of j, and let's say v as w2 of j. Once we declared them as u and v, so also you should know that if u is before v, I mean we have compared these two things, right? So this is coming before this, u is before this. You should keep this in mind. I will explain how we are using it. If graph of u dot find v equal to graph of u dot end, it means if the edge is not been added yet, we will insert it in the graph, and we will keep in degree as plus plus. So we'll check the very first character, very first index where the characters are different, and once we got this, we'll get to know that u is coming before v, and if the edge is not added yet, we will add it, so that it could get something this way, right? After adding this, I should keep this as v, and once you got this, it means found equal to true, which we put false initially, and you can put as break, because we don't need to compare further. We already got different element, right? Different character. And once we are done with this, we'll put something as if not found. I mean, if we didn't found any element, all the characters are same, there is no difference. Or either, let's say if w1 dot length is greater than w2 dot length. It means if ABCD is here and BAA is afterward it, so it is not possible, because anyhow we are comparing from first element, and if there is one letter extra than the later one, there is no point of comparing. So directly we will return it as, that's what in told question, right? Like this. And once we are done with this, okay, so you should know topological sort. So next to it we will gonna perform, once we got all the arrangements, how the nodes are getting connected, we will perform topological sort so that we can arrange them in a particular order. So let's say C is connected to A is connected to B, so C has something invert as 0. That's what I have defined in degree as 0. And A has in degree of 1 from C, and B has in degree of 1. So we will inside the queue we will first insert C, because it has invert as 0, in degree as 0, and there is only one letter, it will get popped, we'll write as C. Then once it is get popped, A will be 0, A invert will be 0 because it has been popped, nothing is attached to it. We will put it inside the queue because it's 0. Again we will pop it and we will write as CA. Then B will be 0 as A is attached to it, so we'll again put B inside it and we'll again pop it, so it's like CAB. So that's what we are using topological sort, so that we can arrange them in a particular order after attaching all the nodes. So that I will explain in the code side by side. So let's say Q of char is Q. Now for auto, we'll declare something entry and we'll iterate through in degree, and if entry dot second equal to 0, that's what I told here, right? If it's 0, dot second means dot first is the letter, that is C, and dot second is the integer which I declared at very starting in map. If entry dot second is 0, we will push it into the queue. Let's say entry dot first. Then after that we will declare something string as result, and also we'll check till the time queue is empty. We'll declare something character as char current, and we will put it as a q dot front. That is, firstly this was this, then A, then B, just like that. And once we have got this as current value, we will pop this element, we don't need it anymore, and we will add it into the result. And once we are done with this, we'll again iterate through the for loop, and we'll declare something as character neighbor, and graph current, that current element. So initially what we have done, we have stored character and all the adjacent value to it, right? So that's what we would be using here. We will be getting all the adjacent element of the current element which was popped, and once we are done with this, we will put in degree as neighbor of minus minus, because as I told, once it has gone inside, nothing will be attached to it, and we will decrease the in degree. And once we have decreased the in degree of the neighbor, we'll check if in degree of neighbor equal to 0, and if it is so, we'll push it into the queue, and it will go again and again till the time the whole queue is empty. And once we are done with this, we will check result dot length. That is one of the condition. If it is not equal to in degree dot size, it means there is no point, because both the lengths are not equal only. We return like this. And at last, if it's not so, we'll return the result. Let me run. So this is the corrected code. If there was any syntax error, you can go through it. And also, if we'll discuss the time complexity and space complexity of it, so we know that we compared pair of adjacent words. So there were total n minus 1 words, n minus 1 pairs, and we compared till we found first different character up to this minimum value. So we'll say that on the worst case, it could be O of m, and while creating graph, we know that the complexity is O n cross m. And also we have gone through the topological sort, so its complexity is basically OV plus E, vertex and edges, and there are total 26 letters, or 26 vertex, and E, that is 26 minus 1, 25 edges. So that is O of 26 plus 25, that is almost O of 1. So overall complexity we can say as O of V cross E. That is the while creating graph. And if we talk about the space complexity, then we have created two unordered map. The first unordered map has taken vertices and edges as well. So it is again 26 plus 25, that is O of 1. And while creating this map, it just took vertex, that is O of 26, and again it is around O of 1. So we'll say that space complexity is somewhere around O of 1. So that was all about the question, and let me submit it. So yeah, thank you.